Hey, this is Mr. Warden. Here's a key for the exit ticket 14.3. So here we go. So hopefully we've started chapter 3. If you've started chapter 3, then, or you paid attention to the conversation about chapter 3, you got introduced to some of the postulates for proving triangles are congruent. So one of the postulates is angle, side, angle, or ASA. And what that means for a triangle is if you have two triangles, okay, and this side and this side are congruent, and this angle is congruent with, say, this angle, and then this other angle is congruent to this angle, then these two triangles are congruent. So this is called angle, side, angle, because you've got two angles and their included angle, which is the one in between, or sorry, included side, the included side, two angles and the included side, the side that's between them, these are called excluded sides. So two angles and the included side, then we can prove that the triangles are congruent. So let's take a look at this. We know that angle 1 is congruent. We know that angle 2 is congruent. We also know that EF is congruent to HF. So can we prove that these two triangles are congruent? In fact, yes, we can, because there's one more angle, angle 3, and another angle 4. So these two are also congruent because of vertical angles, which you learned about in 2.8, and you've probably heard about before. So after the givens, you would say angle EFJ is congruent to angle, so EFJ, and then we got to label it HFG, and I'm labeling it that way because that's the order in which the points appear. So this J corresponds to this G. So EFJ, and I start with the one that corresponds with HFG. Okay, is congruent to HFG by vertical angles. Okay, and then now I know that the triangles are congruent. So I'm going to label them carefully. So triangle EFJ is congruent to triangle HFG. Now that's EFJ and HFG. So F corresponds to F, E corresponds to H, J corresponds to G, and that's why they're ordered in that way, by angle, side, angle. Okay, so let's keep going here. Again, we got angle, side, angle on this one. So we know that SV bisects TVB and TSB, and that tells us something. That tells us that we now have this angle is congruent to this angle because it's been bisected. We also know that this angle, and that's another way we can show angles are congruent, is congruent to this angle. Okay, so angle TVS is congruent to angle BVS. So we now have two angles, and then there's this side we can use, which is congruent to itself. It is itself. So the reflexive property, I give you a hint that you're going to need it. The reflexive property is part of that. So after the givens, okay, we can say angle TSV is congruent to angle BSV by definition of angle bisectors, and then angle TVS is congruent to angle BVS by definition of bisectors. Okay, angle bisectors, I should be specific. Okay, and then segment SV is congruent to segment SV by the reflexive property. Okay, things are congruent to themselves. Okay, so now we have, let me correct that. Now we have that the triangles, triangle TSV is congruent to triangle BSV by angle, side, angle, because we have angle and then an included side and angle. Both of those are the corresponding angles, and their included side are congruent, and so the two triangles are congruent.